Okay, so we're going to be talking about aircraft systems and flight instruments. So the first thing is a fuselage, right? And a fuselage can be several different things. It can be tubular, it can be what I call monocoque, which is something like a soda can, right? So the fuselage is everything except the wings and the tail. So I said monocoque. I said soda can after that. If you take a soda can, an empty soda can, you can stand on that soda can and nothing will happen. But the minute you even so much as put a little squeeze on that soda can and try to stand on it, it'll collapse. So the same with the body of aircraft. It used to be that they just made the body all by itself. Then he discovered that even a tiny little dent would ruin the structural integrity of the fuselage. So they started putting stringers on the inside of the fuselage to make sure that it didn't go the way of a soda can. So we're going to be seeing a lot of aircraft this afternoon to give you an idea of the kinds of structures that fuselage represents. So we're going to be looking at everything from small little aircraft to biplanes to commercial jets. There's the 140, very typical light aircraft, low wing, and it also has what we call a monocoque fuselage. You can get in the back and open up one of the doors, and you can look all the way through the back to the tail, and you'll see mostly skin, but you'll see stringers, that is, pieces of metal that go around on the inside of the fuselage. We also have fuselages that are made of tubular steel covered in fabric. Here's a good example. This is a Husky Scout, and as you can see, it has giant wheels on it, so it has been modified for bush flying in Alaska. And one of these days, maybe I'll bring in a DVD on how bush flyers work. They actually land in rivers. They land on sandbars. It's just amazing what they're capable of doing with the big tires and an engine that's very, very powerful and can nearly hover that aircraft. So if you have any idea about bush flying in Alaska, this is probably what you'd be doing. Okay, here's another one, fabric covered, and it looks to me like it has metal wings, but I doubt it because it's old enough to have had all fabric. The paint is beautiful. The reflection underneath probably is just simply the beautiful paint job that was put on. Okay, metal. And again, that's nearly all aluminum. I don't think there's an aircraft out there made of titanium. Probably the SR-71. The SR-71 is the fastest aircraft in the world, and it was developed by the Skunk Works at Lockheed. And it's an amazing aircraft. It goes so fast, like 5,000 miles an hour, faster than a bullet, actually. It goes so fast that the body expands, and therefore it stops the fuel from leaking out. Fuel, an interesting aircraft. Anyway, here's a good example of one that's metal. Here's another one that's metal, Piper Comanche. Just keep in the back of your mind that, and for note purposes, there are only fairly major ways that you can build a fuselage out of some material. So it's fabric, it's metal, and in some cases it's all wood too. There are aircraft out there that are built of all wood, so it could be wood, metal, fabric. Here's an interesting fuselage. Has anybody ever seen this before? Okay, Chris. It's an aircraft that carries parts that have been made for commercial airliners. So commercial airliners are not made in one big section. They're made in several sections, and then they're all bolted and welded together. So this goes from, for example, it might go from Alabama, where parts of the fuselage are built, and then it will carry it to Seattle, Washington, where the commercial airliner is finally assembled there. And these things are constantly in use because of the fact that the commercial aircraft builders like Boeing have their parts scattered all over the world. Actually, Italy and Japan make very crucial parts for the airplanes that are coming off the assembly line right now. Here's another fuselage, like a boat, right? It's an amphibian. That was taken on a picture in Miami, right next to where the cruise ships park. And that particular airline, Chalk's Airline, very world famous. They've been in business, 100 years. And they travel from Miami to all the islands of the Windward Islands, the Lesser Antilles and the Greater Antilles. They just specialize in doing that, so they don't have to worry about airports. Yes, sir. Pardon? No, I've not gone on Chalks. I have gone on seaplanes, but not Chalk. Yes. Want to do what about the category? You need to speak a little bit more clearly, huh? What? As I said, you can pick aircraft, you can pick a person, and you can pick an event. Now, an aircraft is pretty, that's certainly an aircraft, isn't it? Yeah, sure it is. Sure it is. It flies. Right. Yeah, category's fine. Okay, so now that we've looked at fuselage, the next thing is what is called the empennage. That's kind of a French word, but I'd rather say tail feathers. In fact, I think you'll find that most of the people out in the world of aviation don't really use the word empennage. They use the word tail feathers. And that means that certain things are going to be considered as part of the tail feathers. And you know what that looks like, right? I mean, there's a vertical fin. Let's see. Hold on a second. Stabilizer. So this is made up of two things. It's made up of a fixed portion that is bolted to the fuselage, and this is a movable thing back here. This is called the rudder. This is called the horizontal stabilizer. And you want to make sure that you can distinguish between the two, because I'm pretty sure I might ask you that on a quiz. So you need to know the difference between the vertical stabilizer, which is fixed to the body of the aircraft, and the rudder, which is also fixed, but it's movable. Here's another one. Here's a Beechcraft King Air 200. And you can see in the back the difference between the fixed portion, which is ahead of the tail, in the back, the rudder. So all of this, including the vertical stabilizer, the rudder, and the horizontal stabilizer, and the elevator, are all part of empennage, tail feathers. Okay, here's a good idea of a breakdown graphically that shows the different components. You might also want to pay attention at the moment about the angle of attack and the angle of incidence. The angle of incidence is the angle that the wing is bolted to the fuselage. And that's just a design factor. The angle of attack is how the aircraft is flown. Okay. Don't worry about that right now. We'll get into aerodynamics later. I just want you to recognize that those particular pieces of information are important. Like the wing chord line is the line from the rear end of the wing to the very tip of the wing. Right? That's called the chord line. And that comes into play later on a lot. So here's a Americanized Boeing 747 some years ago, and you can see that for significant aerodynamic reasons, the tail is huge, isn't it? Huge. It's because they need they need the ability to keep the yaw of the aircraft, keep control of the yaw of the aircraft. And of course, the bigger and heavier the aircraft, the more tail surface you need, unless you're a fighter plane. If you're a fighter plane, all bets are off, because fighter planes operate kind of in a bit of a different realm of aerodynamics. So when you're looking at this picture, you want to make sure that you understand the fact that this is the fin and this is the rudder, but also when you see something like this with kind of like a door there, that means retractable. And I'm sure that one of my questions might very well be, can you distinguish by looking at an airplane whether it has retractable gear or fixed gear? And we'll cover that coming up in the presentation. But when you're looking at an aircraft, any aircraft, very quickly you can scan the aircraft and get a pretty good idea of its performance, because if it has retractable gear, it's going to be much faster than an airplane that has a fixed gear. All right, so we got horizontal stabilizer. This portion here, right, it's fixed in place. It doesn't move. This is the elevator. The elevator. Elevator controls what? Controls what? Attitude? Altitude? There was a question on a quiz about that, right? This moves up and down. So it changes the pitch angle of the aircraft, right? So if it changes the pitch, what changes? Airspeed, right? Remember? Pitch controls airspeed, power controls altitude. Okay, rudder. We just talked about rudder, so this should be pretty obvious to you when we look at what is really the rudder. Okay, here's that big twin-engine airplane I used to fly. This is that Mammoth Airport in the wintertime, as you can see. Again, this portion back here is the rudder. This sliding line between the vertical stabilizer and the rudder. When we get into aerodynamics later on in the semester, the information regarding what controls what will be more apparent. But I do want you to sort of start connecting things, like the elevator controls the pitch and the pitch controls airspeed. Okay? I mean, I might ask you that on a quiz. I don't know. Possible. Okay, elevator. Now, there are two things important about this elevator. Number one, the fact that you can see it's tilted down, but at the same time, there's kind of a funny little portion here that's down even further. That little portion is called a trim tab. And a trim tab is designed so that setting it by using the trim wheel in the cockpit, I can set the speed. I can set the speed. So I don't have to use my hands on the control wheel. I don't have to push and pull on the control wheel in order to set the pitch. If I want to fly at 90, I hold the wheel at 90 and then I trim off the pressure, and all of a sudden the pressure goes away, the airplane stays at 90. So this controls this device in coupling this device along with this elevator means that you can set and leave alone the airspeed in nearly every aircraft. Okay, landing gear. We talked about just earlier about the fact that if you pay close enough attention, you might be able to tell the difference between conventional, which means a tail wheel, and retractable, and tricycle gear, which means a nose wheel. So here's a conventional tailwheel airplane. By the way, a couple of years ago, not too many years ago, this was used in filming Indiana Jones, a movie by Indiana Jones, and Harrison Ford was here, and George Lucas was here. I don't know whether you guys are familiar with Harrison Ford and George Lucas and the movie called Indiana Jones. Yeah, okay. But this was used in that film. So that's a conventional tailwheel airplane. Here's another conventional tailwheel airplane. Because you can see the tailwheel. Everybody can see the tailwheel right down at the bottom there in the back. Okay. Here's another fixed gear airplane. These airplanes that I'm showing you, a lot of them are actually flying out of Chandler, or have been flying at Chandler, because a lot of the photographs, I think most of the photographs here I've taken. So give you some idea of where they are. Okay, so now the next one is tricycle, a nose wheel. Okay, there's an aircraft that has a nose wheel. Now I'll tell you that the major difference between a conventional gear airplane and a tricycle gear airplane is the fact that, first of all, it's harder to fly a tailwheel airplane. That's number one. But at the same time, it's often used for bush flying because when it's sitting on its tail, the propeller is farther off the ground. Okay? And because the propeller is farther off the ground, it's less likely to hit the propeller on the ground. If when taking off from a dirt strip, you might have gone into some sort of a little depression. So a lot of bush flying, they use tailwheel airplanes to keep the prop farther off the ground. But that's about the only advantage I can think of for a tailwheel airplane. They are very difficult to fly. Pardon? Yes. Well, how do you want me to measure? If a tricycle gear airplane was 5 on the difficulty scale, a tailwheel airplane would be a 10. That good? Okay, here's another another tricycle gear airplane, and it's retractable, isn't it? Yeah, definitely retractable. That's called a King Air. Beautiful airplane. Later on, we'll talk about the engines. You may want to make a note of what the engine looks like. Kind of a funny big old exhaust coming out the side there. We'll talk about that. Okay. So fixed gear and retractable. Everybody get that? Fixed gear and retractable. That's fixed gear, as you can see. And it's also tailwheel, isn't it? And very difficult to fly. Even though Alan Buckner swears that it's much easier for him than it is for other aircraft, that's because he loves that airplane. He built it himself. Here's a retractable on its way down to Baja. We were flying together, 2 aircraft. Actually, there were times when I was flying down with 5 aircraft out of my Piper dealership at the Burbank Airport. I would take people down there once a month. We'd all pile in the aircraft and head down to Baja for the weekend, usually a long weekend. We'd down Friday and come back Monday. Great flying and great fun, and it resulted in me being able to sell a lot more airplanes than my competitors. Here's a Piper Archer that's being brought in by 2 ladies who went all the way to Vero Beach, Florida. First time they'd ever gone cross country, and it was in January, as I believe, and they were just taxiing in, so happy because they got stuck at a place called Crestview, Florida, because it fogged in. They kept calling us saying, "Please come and get us." No, we're not going to come and get you. You have to make your way back to Burbank. This is the Burbank Airport. That's my facility there. You can see a Tomahawk in the background. I had 6 of them at one time. I had the largest fleet of Tomahawks on the West Coast in 1978, 79. Okay, we're going to look at power plants now, right? Power plant simply means what causes the airplane to go through the air. So, you know that piston engines have been around a long time. You can go out and we'll, if you haven't taken a tour, I guess you did take somewhat of a tour before, but if not, we'll go out together and we'll take a look and see. They've got piston engines on stands. They must have 30 of them out there. They also have jet engines. They also have turbine engines. They also have funny little engines and a glider that's hanging upside down in the ceiling. Anybody ever notice that? Yeah. Interesting, huh? It's called a self-launch glider. Okay, piston engine. So there's a piston engine. You can see the cylinders of that aircraft in a circle around, and they're on the outside. Why would you think they would put the cylinders on the outside? How about cooling? Right? How about to keep it cool? Because most aircraft, general aviation aircraft, are air-cooled, not water-cooled. There are water-cooled engines out there, but they're probably represent less than 1% of all the piston engine aircraft out there. Okay, turbine engine. There's one on the Beechcraft King Air. There's an up-close look at it. So a turbine engine is a jet engine with a propeller, right? Now, that might be carrying it a little too far. It is a jet, and does have a propeller on it, but it's not quite the same as the jet engines of today. So, if you know a jet engine, the air goes in one end and it blasts out the other. Well, the air comes in here, goes all the way through, and comes back and is exhausted out here. I don't know why Pratt & Whitney did that. That was something that I still haven't been able to figure out why they would bring that exhaust from the jet engine all the way forward and then exhaust it out up that far, but they do. So a turbine engine is a modified jet engine with a propeller. Okay, so part of the systems on an airplane is the landing gear. We talked about tail wheel and nose wheels and fixing gear and retractable. So we will. Oh, I'm sorry. We already talked about that. Now we're at power plant and jet engine. So let's look at the jet engine. This is a picture of a Boeing 707 taken probably back in 1960 sometime. I took that at O'Hare Airport in Chicago. Anybody notice anything unusual about it? The exhaust, huh? Yeah. They were so filthy dirty back then that people started complaining, and they were also terribly noisy. I mean, they caused so much havoc and breaking people's windows that lived near airports. Property values plummeted if you were within 5 miles of a major commercial airport. But you can see that was just typical. That was not an unusual picture. That was typical of every aircraft that took off out of O'Hare Airport, and I'm sure any airport around the country. So since then, what they've done is not necessarily they've cleaned up the fuel, but now they use less of it because now the jet engine drives a fan. And the fan brings in pure air along the side of the engine and exhausts. The fan drives the air around the engine and out the back. They initially called them fan jets. And it's because a high percentage of the thrust comes from not the jet engine, but from the air being driven alongside the jet engine. So today, the fuel economy, the noise reduction, all of that has made, as you know, made great strides because you can hardly even hear those aircraft overhead. Not only that, but power-wise, we have aircraft like the Boeing 777 that owns only 2 engines, and yet it flies worldwide. So the advances have been very, very significant, especially in cleaning up the environment. Here's the TWA, Trans World Airline Boeing 707, that is in somewhat stable flight, So he's not accelerating and takeoff. So the amount of dust and smoke coming from the engines is much less. Okay, wings high and low. There's going to be a difference mostly between Cessna, which has specialized in high wing aircraft, with the other aircraft manufacturers who have specialized in low wing. And I can tell you, because I've sold against all of them as a Piper dealer, it's very easy to sell against a high wing airplane. Because if you're flying along, you're going to make a turn, so you're looking this way. Huh? In a high wing airplane, you start banking the airplane, and now the wing comes down and blocks your view. You can't see anything, can't see where you're turning. Whereas a low wing airplane like a Piper, when it turns and banks to go left, that wing goes out of the way, and now you have a perfect view of where you're going and whether there are any obstructing aircraft that might be in the vicinity. So that's just one of the elements of the difference between high wing and low wing. The other is stability. The stability of a high wing aircraft is much less than the stability of a low wing aircraft. If you go out we have a chance to go out and we can test that theory. They have a high wing Cessna sitting over here. It's a 210. You can go up with your finger and you can rock the entire plane by pushing your finger at the end of the wing. That's because the landing gear is so narrow because it has to come out from the fuselage. It can't come down from the wings. Huh? So the difference then is if you go up, there's a Cherokee 6 sitting outside, and you go to that aircraft with your finger, you'll break your finger before you'll move the airplane. So there are a number of big differences between the two. Here's the Cessna 210, very much similar to the one that's sitting out here. My friend and I flew that down to Baja, probably, 25, 30 times. And again, it's fun, and if you're doing search and rescue, it's probably better to have a high wing so you can look straight down. And then here's another airplane we took into Baja, a low wing, Piper Warrior. Beautiful flying, beautiful airplane. I hope you all get a chance to get involved in general aviation and tour the country, and tour Mexico, and tour the Bahamas. Okay, so aircraft systems, wings, single and double. There's a single wing. Single wing. That was taken over the Gulf of California. Double wing. There really isn't any advantage to having two wings like that in a biplane, just because for the amount of weight and construction involved in the airplane, two wings do not produce that much more lift than a single wing would. And so, for the most part, you're going to find that when you see a biplane, an airplane with two wings, it's probably going to be pretty old, because for purposes of manufacture, there may still be a manufacturer or two that build biplanes, but they probably do it for aerobatic flying rather than for regular flying. They're expensive, they're a little hard to fly, and they don't add an awful lot. So if you've got all the money in the world and you want to go into an aerobatic contest, then you can buy yourself a Pitts, which is a two-winged aircraft, an aerobatic aircraft. But I guess they're nostalgic. So if you like the golden age of aviation, and you'd like to be able to fly in an aircraft that flew 65 or 70 years ago, biplanes are fun. Okay, propellers. When we say fixed and variable, we mean that each blade is fixed on the hub and it can't turn, it can't change. That's what fixed means. It's there, doesn't change, and the angle of the blade remains the same. That's what fixed pitch means. The pitches this kind of turning this way. Right. So why would you want to turn this way? Well, if you're going to do a lot of climbing like we do at Avenal for gliders, you would want to have the tow plane with a climb prop, which means that it's taking a bigger bite of the air, right? For long distance flying, you can get away with not such a big bite, so you wouldn't have quite the angle on the blade. But they're more expensive. The variable pitches are more expensive and need more maintenance. I don't know whether you can tell or not, but if you look carefully, you can see the extra space in here because these blades turn. And that's one of the things that happens all the time. If you hear airplanes taking off and you hear or something with a change in tone, that change in tone means the guy or the woman is probably pulling back on the propeller control and changing the pitch, even though the engine sound stays the same. The other thing that variable pitch props do is that maintain a constant speed of the engine. So if you set the engine to turn at 3,000 RPM and in flight you want to change the pitch changes, but it changes in such a way that it keeps the RPM of the engine the same. It's called a constant speed prop. That's also the same thing as a variable pitch prop. It's called constant speed. Constant speed prop. And you'll see that wording in the literature often, both ways, variable pitch and constant speed. And the constant speed means that by changing the blade, it continues to keep the engine at the same speed in RPM, revolutions per minute. Everybody understand what RPM means? Revolutions per minute. Okay. Here's the airplane that I flew for a couple of years, and it again, it has 3 blades instead of 4, but the same thing is true there. They have those blades turn in response to the control in the cockpit. What do you think these things are? Speak up, loud. Nobody? Yeah.
He said rudder. He said
rudder. Rudder? Wait a minute. Yeah, go ahead.
He said fixed.
In here.
He said fixed.
Fixed? No, I said, what are those black things? What are these black things right here? Boots with wires in them. Makes that part of the prop warm. Keeps off ice. Same with the leading edge of the wing. The leading edge of the wing has black rubber boots on it. And when you get into heavy icing, you have to have some way of getting that ice off. Let's see if we can. Yeah, you can see part of it there. Let's go back a little bit here. See if. There, see the wing? Yeah. Pardon?
How does it affect?
Well, it throws the whole process of the engine off, right? It increases the load on the engine, which also decreases what? Well, it does decrease the speed, but it also decreases the shape of the propeller. And the propeller is shaped so that it's like a vertical wing, right? It has the same cross section as a wing. So with icing on it, that's also the problem with icing. When you get icing on the wing, it changes the shape of the wing. It changes the nice smooth curvature. There was an accident called Air Florida way back when, and it was in the wintertime, and the 2 pilots were in the aircraft. They were getting ready to take off out of Washington National, and they had aircraft de-iced. So that meant that somebody had gotten the necessary icing off of the airplane, but it took a long time for them to taxi and waiting in line to get up to the point where they could take off. Well, they took off, but they had too much icing on the wing, and as soon as they got out of what we call ground effect, they crashed into the Potomac River. And that's because even a small amount of ice can make a radical change in the lift quality of the wing. The lift quality of the wing. So keep in mind, if I ask the question, what does ice do to an aircraft? Would that be an interesting question, wouldn't it? I might. Yeah, maybe I'll think about that. Yeah. Can you? I'm sorry. Can you what?
He goes to the restroom. He's asking if he goes to the restroom.
The restroom? I'll give you all a break here pretty quick. Okay? I'll give you a 10-minute break in 5 minutes. You know, one of the things you guys need to learn, I think, not because I'm hard of hearing, but because when you speak in the rest of your life, if you enunciate clearly and speak out, you will be much better off. People who tend to, not you, but anybody that tends to mumble a little bit is not thought of as well as people who speak openly and clearly. Huh? So I think that for your own purposes, it would behoove you to get to the point, and well, you guys are going to have to make a presentation on your essay, right? So you'll have to come up here and you'll have to be able to speak about your essay. So those kinds of things, if you get to the point where you can enunciate clearly, speak openly. Okay, so so this is the last one. Now we're going to talk about flight instruments. And this is an interesting part. Okay, I'll tell you what. I'll give you all a 5-minute break. And then we'll start on flight instruments. Okay? Be back here at 16 minutes after